Hi, I'm Fallyn and I'm a senior in engineering physics. This video I am going to show and explain to you my project of building a sine wave pendulum. Before I get started, here's some background information that might be helpful. A sine wave is a mathematical curve that describes a smooth, repetitive oscillation. Waves are made by adding together multiple sine waves. The sine waves have a pattern that repeats. You can find the wavelength of a sine wave by measuring the length or distance between one peak of sine wave to the next. Sine waves, when added to other sine waves of the same frequency and magnitude, retain its wave shape, making sine waves important to physics. Sine waves are the only periodic waveform that have this property. Sine waves are created from the cosine of theta and the sine of theta. The angle theta ranges from positive infinity to negative infinity. By changing the sine wave's amplitude, phase, and frequency, or by adding together an infinite number of sine waves, the sine wave's wavelength could be smaller or longer, and the entire shape and form of the sine wave could be altered, producing its own unique pattern. Every possible waveform and function in existence can be gathered by just adding together sets of sine waves. You can also add certain sine waves together to create non-repeating waveforms. In my demonstration of sine waves, the length of the string gradually becomes shorter to show the frequency spectrum of a waveform and signal. The signals and waveforms we see in real life have a beginning and an end. The waveforms can be thought of as an infinite number of sine waves, and each sine wave has no absolute beginning or ending. All the sine waves cancel each other out at all times except for when the signal is present. All the sine waves we see in real life have been present since the beginning of time and will continue to be present throughout all eternity. When building my sine wave pendulum, I knew that the shape and the mass of my tennis balls didn't matter. I also knew that air pressure and friction were neglectable. The pendulum moves in a single plane in oscillation, and each pendulum will oscillate the same way. As the string length is shortened, the amount of time it takes for one oscillation to occur will decrease. Here is a picture of a sine wave. The amplitude represents the measurement between the top and the bottom of the sine wave. The crest is the top hump and the trough is the bottom hump. The wavelength is a measurement between each hump. The direction of my oscillation is going this way, back and forth. The amplitude represents the length of my string. So when I shorten the amplitude, my string length becomes shorter and the speed it takes for one oscillation to occur is decreased. To find the length of my strings, I use the formula T equals 2 pi times the square root of length divided by gravity. T stands for the period, L stands for length, and G stands for gravity. To find my longest string length, I took the square root of that divided by gravity and multiplied by 2 pi. Then I decided how many oscillations I wanted for my entire dance. I multiplied that by the number I just found and found the time for my entire dance. Then, to find the rest of my string lengths, I added one oscillation, divided that by the length of my dance, and found the time it takes for one oscillation to occur. Here is an example of the calculations I did to find the length of pendula 13. I added one oscillation because the string is getting shorter, divided that by the time of my dance, which is 42.57 seconds, and got 1.2163 seconds for the time it takes for one oscillation to occur. Then I took that number and plugged it in as T in the formula. After solving the equation, I got my string length to be 0.367604214.9 meters. Here are some clips of my building process.